Okay, Scholar Practitioner Leaders, SPLs, Data Scientists, welcome back to our 2025 Fall Statistics for Data Science, section MSDS 531 A01 for our first by term. Okay, this is all lecture 2 of 4, guys. We just finished up section 1 of 4, where we talked about week four's previous material. Now, this lecture is all about, as I mentioned, our week 5. However, now I want to go back and talk about our week four's 2 quizzes, as I alluded to in section 1 of 4. Okay, so we had 2 phenomenal quizzes, guys. As I stated in the previous lecture, you guys did very, very well, being the scholar practitioner leaders that each and every one of you guys are. So I just want to go over the test bank a little bit because those 2 quizzes were really, I'm not going to say they was challenging, but I like to think that I put a good something in front of you guys just to make sure that I wanted to see that you knew the material that we have been discussing here in our curriculum, okay? Especially the linear regression, which was quiz number 3 that I had mentioned last week, right? And then the same thing with quiz number 4, which is the multilinear regression, okay? So we had those 2 great quizzes. And the good thing about the quizzes, guys, is that it carried over from week 3 all in our week 4 material. So basically, you was really being quizzed on both weeks, which I kind of like how I did that for you because that showed me that you had week three's material pretty much in your pocket. Well, you did have it in your pocket. Same thing in week 4, you had that one also in your pocket. And that's why I told you guys, make sure that you can differentiate the various types of regression because week 3 jumped right into the deep dive in week 4 about the various types of those 7 regression areas that I was telling you to make sure that you're able to differentiate. Because if not, you're not going to do well on the quiz. But that wasn't the case at all. So don't take that the wrong way, anyone. Everybody did well on the quiz. And I mean literally everybody. I think the bell curve on the scoring for the quiz was probably right at 95%, which is great. So, and you had the on the low end of the bell curve, you had the others, I like to call it, scoring. However, but that was still in the 90s. So all the scoring was really well. So for the most part, the class average was right at 95. So that is phenomenal. So let's go ahead and go over each of our quizzes. And then after this lecture 2 of 4, on our next 2 other lectures, we will finally jump into this week's material, which is for our week 5. Okay, so let's go into the first quiz. That is quiz number 3, and that's all about linear regression. So I'm looking here, guys, and I'm going to go through the test bank. Before I do that, let's outline the quiz first, because we know, as I mentioned last week, there was going to be 20 questions. And as you can see, I was true to form because this was pretty much like we did in week 2. Same type of setup as I told you last week, 20 questions. It was multiple choice questions as far as those types. And then you also had the true and false questions, right? So you had a 50% chance of getting those right, and then you had a 25% chance of getting the multiple choice answers correct, okay? Which, all in all, you had a pool of questions of 20, okay? That's the reason why they was worth 1.75 each, which, if you do the math, it adds up to a 100% test score, okay? So, again, everybody did very, very well. And I was really, really happy in regard to the scoring, as I previously mentioned. So, but there was a couple of areas that actually hung up some of you guys, actually a lot. And those are the ones I want to go over. So let me pull those up real quick. It's going to take a second while my computer gets it all configured. And give me 1 second, and then it should populate. Here we go. Okay, so I just want to go over the ones where I know for a fact because I can see here in the bank which ones where you guys missed a lot. Okay, here's one that sort of threw you guys off, and I can see why it was a little tricky because of the math that was involved. Okay, and this was a multiple choice question. Okay, and as I alluded to, it was worth 25 points. 25% each, which thus equals 100%. So you had a 25% chance of getting it right, okay? Whereas multiple choice is 50, okay? Okay, so in this multiple choice, it was all about a multiple regression analysis, including 50 data points and 5 independent variable results in, and you had that sigma equation of sigma 2 over I equals 40. So the multiple standard error of the estimate will be, okay, and here it is. Here's the tricky part, guys. The overall answer, will it be 0.901, or will it be 0.888, or will it be 0.800, or would it be 0.953? The majority of the class chose C. And that lets me know a lot of people didn't really know the answer because it wasn't C 0.800. It was actually D, which was 0.953. So that was the correct answer. So that's how you know a lot of people got hung up when everybody's selecting C and that's not the answer. So that's why I wanted to go over that one. But yeah, that was all about multiple regression analysis. And that's where I've told you, you have to make sure you know your regression, okay? Here's another one. This was a true or false one. Everybody chose the wrong answer because there's a lot of indentions on the one that was chosen incorrectly. So a regression analysis between X equals sales in 1000s, right? And Y equals advertising, which is in the dollars, okay, resulted in the following least square line of, okay, you had the lowercase y equals 84 plus 7x, okay? So that's y with the hyphen over the top of the y. You guys know about that. This implies if there is no advertising, then the predicted amount of sales in dollars is $84,000. So you guys know about what it implies, right? So is that true or is it false? You guys, a lot of you chose false, which is wrong. The answer was actually true. So the correct answer was true on that one. When you're talking about regression analysis between X value for sales in thousands and the Y in advertising, which equals the result in dollars for following the least square line, okay? And then you have the line y equals 84 plus 7x, as I just previously outlined, with the y having a hyphen over the top of it, okay? Which it came up to be $84,000, which is actually true. Okay, so that was pretty sneaky, guys, but I wanted to make sure that you guys really understood what regression analysis is truly all about, okay? So that was one of my favorite ones, actually. Okay, what was another one where I felt like you guys, yep, this one right here. Okay, so this is another true or false one, okay? This was about a useful graph in almost any regression analysis. There it is again, regression analysis, right? Is a scatter plot of the residuals on the vertical axis versus fitted values on the horizontal axis, where a good fit not only has small residuals, but it also has residuals scattered randomly, okay, around zeros with no apparent pattern. Is that true or is that false? Not too many of you chose true, but everybody chose false. So which one you think is right? Based on what I said last time. It's not true because it's not false because when everybody's choosing false, that means the majority of the class got it wrong. It was only the few people that got it right. It was true, which was the correct answer. True was the correct answer, not false, and everybody was selecting false, 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 false. No, the answer is actually true. Okay. When you're talking about the useful graph in almost any regression analysis is a scatter plot. You guys know that of residuals on the vertical axis versus the fitted values on the horizontal axis, where the good fit is not only a small residual, but it has residuals scattered randomly around zero with no apparent pattern. You guys know that that's true. That's the perfect example of a scatter plot. Okay, so the answer was true on that one. Okay. Alrighty, so let me see. Okay, for this quiz number 3 about this linear regression, a lot of people miss this on the multiple choice. So I want to truly definitely go over this one because I was quite surprised. Okay, approximately what percentage of observed Y values are within one standard error of estimate when you're talking about the S and the lower numeral for that? It could be any numeral, Z, Y, X, Y, whatever, of the corresponding fitted Y values. Is it 67%? Is it 95%? 67% is A, 95% is B, or is it C, 99%, or is it letter D, 99.7? When you're talking about the approximately what percentage of observed Y values are within one standard deviation or one standard error of estimate, when you're talking about lowercase g, e, or whatever letter it want to be, of the corresponding fitted values is actually A, 67%. Okay. For the approximately what percentage of observed Y values within one standard error. Okay. It's always 67%. Okay, guys. So those were the ones that I found out that you guys really struggled on this first quiz, this linear regression quiz number 3. So I was kind of like, wow, I got to go over this a lot because it was a lot of people that struggled on the initial quiz. But the second quiz wasn't that bad. So, and that was the multiple linear regression. Everybody did really well. So I think it was like only one or two things that I saw that the majority of the class may have struggled on. I'm going to talk about those two areas right now as soon as I pull up the test bank for the multiple linear regression for quiz number 4. Okay, so it's populating now, guys. Just I think it was only one or maybe two. I think it was two areas that I saw where you guys struggled. Okay, so I'm pulling those up now. Okay, here's one. Yep. It was multiple choice, A, B, C, or D. It was all about in regression analysis. We consider models of the form y equals f in parentheses x1, x2, blah, 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 all the way out to whatever, plus E, where E represents what? Is it A random disturbance? Is it B, actual residuals? Is it C, an additional predictor? Or is it D, the R squared term? It was actually a random disturbance. Everybody chose C. When I mean everybody chose C. So it's a random disturbance, guys. And yeah, so everyone missed that. And then here's one other area, one that I see a lot of people hitting on, but completely wrong. That was the wrong answer. Where was it at? Okay, here it is. All right, it's a multiple choice question. Haha. So the actual value of a dependent variable will generally differ from the regression equation estimate due to, is it A, unaccounted for random variation, or is it B, the inability of the nonlinear solver to find optimal values, or is it C, not building the regression model with enough data, or is it D, the model R squared not being equal to 1? A lot of people chose C, so you know what that means. Wrong. The answer was actually A, an unaccounted for random variation. That was the correct answer, not C, not building the regression model with enough data. It was actually A. Okay, guys, and that was it. That was the only two that I noticed here on the fourth quiz. So outside of that, guys, everybody did well. But like I said, for the most part, everybody did really well on both of these quizzes. So congratulations, everyone. When I come back, we'll start our week 5 materials on lecture 3 and 4. See you in a bit. Bye-bye.